All right, so let's talk about binary games. If you're not used to hexadecimal and binary, you better learn it. So here's a few lessons and some homework where you can learn it, trying to model these after the Khan Academy. So nibbles, where I'd start. So in base 10, as we know, this is what we now normally think of. You have numbers, digits 0 through 9. And if I write 147, you know the 1 is the number of hundreds, the 4 is the number of tens, and the 7 is the number of ones. Or you can say 1 times 10 to the 2, 4 times 10 to the 1, and 7 times 10 to the 0. That's the convention. So you have a ones place, a tens place, and a hundreds place. In base 2, you only have 0 and 1. And so the one on the right is the ones place, and the other is the twos place. So 1, 1 means 2 plus 1, or 3. So you got a ones place, a twos place, and a fours place as you go to the left. So this is 5. 4 plus nothing plus 1. So you can count to 7 with 3 bits. 0, 1, 1, 0 is 2. 1, 0, 0 is 4, because this is the ones, twos, and fours place. And 1, 1, 1 is the biggest possible number you can get with 3 bits. 4 plus 2 plus 1. And if you want to make a nibble, which is half of a byte, you have 4 bits, and you have ones, twos, fours, and eights, and that's all there is. So there's only 16 possible nibbles, and 1, 1, 1, 1 is the biggest one, which is 15. 8 plus 4 plus 2 plus 1. One that's easy to remember is that 10, 10 is 10, because it's 8 plus 2, and so on. So if you know your nibbles, then you're getting there. That's the start. So you've got a challenge here to earn some points by getting the nibbles right. So here, for example, what's this one? 110? You can put it in the chat. Six. There, I see the right answer up here. That's 6, because this is 1, 2, and 4. So that's 2 plus 4. That's 6. How about this one? 1101. I got 11 and a 13. Yep, 13 is better. It's 1, no 2, 4 and 8. The 4 and 8 is 12. One more is 13. So that's 13. How about this one? 1001. Yep. Again, that 12 is wrong, but 9 is right. It's 1, 2, 4, 8. It's 8 plus 1 is 9. All right. And after you get, I think, 5 or 10 of these right, you'll get a flag you can put in the scoring engine. So that's nibbles. Then let's take a look at bytes. And we'll start by doing bytes the hard way, and we'll get to doing bytes the easy way. I think we probably get along. So we talked about base 10 and base 2, and last time we saw the nibbles. Here's counting to 15 in base 2. So now 4 bits make a nibble, but 8 bits make a byte. And this is the way I did it for years. You extend the same logic. 1, 2, 4, 8. The next bit is 16s, 32s, 64s, and 128s. So this number, 1001, 1001, is 128 plus 16 plus 8 plus 4, or plus 8 plus 1. So that'll turn into 153. But it is kind of annoying to do that. And I'm running out of power, so I got to get this rope untangled from everything, which is more difficult than it ought to be. All right. All right. And anyway, so this is one way to do it. So you can do it that way, but it's kind of slow. So let's try some bytes. All right. So let me make this wider so it'll look a little better. All right, now what I did is I put a space in the middle of it, which is not conventional, but otherwise I find it too hard to count to 8 bytes. So how about this one? 111, 0011. What's that in base 10? Okay, I've got it. Might take a little longer depending on how you're doing it. Ah, very good. Gold miners got it. It is 115. Now, might as well tell you how I do it. I do not bother to do 1, 2, 4, 8, 16, 32, 64. What I do is take the left nibble times 16. So this is 7 times 16, which is 112 plus 3. But you could do it the other way. 1 plus 2 plus 16 plus 32 plus 64. That's 115. How about this one? Okay, I got it. Yep, good. V dot, got it almost as fast. Good, a lot of people got it. So this one's pretty easy. 1, 2, 4, 8, 16, 32 plus 5, 37. All right, how about this one? Okay, I got it. Yep, 66, that's right. So this is 1, 2, 4, 8, 16, 32, 64. That's 64 plus 2, 66. All right, let's do one more. How about this one? Okay, I got it. Yep, 76. That's it. Because this is 64 and that's 12, so it's 76. All right. So let's just, you people are doing pretty well. And so let's go up to hex. That's as far as I'm going to go today, and we'll come back to this another day to do the other things. But let's talk about hex while we're here. So hex is the easy way to do this. The easy way to, hex is the perfect, be halfway between a binary and decimal. That's why everybody uses hex to express things in Wireshark and in raw memory dumps and in disassemblers and just everywhere. This is why you all got to learn this. If you're going to be a computer scientist, you got to know hex. So what you do, you take the nibbles that go from 0 to 15 and you just replace it with one letter. You go 0 through 9 and then you use A, B, C, D, E, F for the numbers above 9. So now you have one digit or one character that represents a whole nibble with 16 possible values. And you get used to this. You get used to saying A, C, and E are even numbers, and B, D, and F are odd numbers. You'll get used to it. So 4 bits make a nibble, and that can be 1 hexadecimal digits. In base 10, 0 to 15, in hex from 0 to F. 8 bits make a byte, but what's much easier is to just see it as 2 nibbles, and therefore 2 hex characters. So this one, 1 nibble, 0 through F, and 1 nibble, 0 through F. So this number is 9, and you could do it this way, 128 plus 16 plus 8 plus 1, like we did before, but that's hard. What's much easier is to just see the left nibble is 9. 1, 2, 4, 8. That's 9. The right nibble is 9. 1, 2, 4, 8. So this is 99 in hex, which means 9 16s plus 9. So 9 16s is 144 plus 9, 153. This is what's much easier. So let's try some hex. And that'll be all the binary you do. So try that. Convert that number to hex. And a lot of people make this much harder than it needs to be. Okay, I've got it. Ah, good. Somebody beat me. Good. A lot of you beat me. You just do the nibbles one at a time. So 10, 10 is 10, which is A. This is B, which is 11. And this is F. So it's BF. That's it. If you know your nibbles, you don't have to do any 128 plus 64 and all that garbage. You just do the nibbles one at a time. So how about this one? I can read it right off instantly. And you should be able to, too, after it's a little bit of practice. It's 70, right? Left nibble is 7, right number is 0. There you go. How about that one? That's 81. The left nibble is 8, the right nibble is 1. It's very simple. Good, a lot of people getting it right. This will be the last one. B. That's B and 0 on the left. All right. So that's what I wanted to show you for this one. So there's various challenges here where you do various things in binary, and we'll get back and demonstrate more of them in future lectures. So let me stop this one.